This little video is about Excel for discrete data, so we're on part C. But in this video I'm going to help you have a look at how to process and interpret your data, if it's discrete or categorical, and if you have got more than 2 samples to compare. So in my video here I have decided to look at the increase in the number of yeast cells when they're incubated in glucose broth compared to fructose broth and lactose broth. So these are 3 different categories, which makes it categorical data. The first thing you want to do is you want to generate the statistics. So we're going to go up to our data tab and click on that. And right over here on the right, we're going to click on data analysis. And for data analysis this time, we're going to choose descriptive statistics, because that's what we're going to do. We're going to use statistics to describe our data. So we're going to click OK. In our dialog box, we need to choose which cells are going to be included. So we're going to click on the up arrow to take us out, and we're going to choose all our data. We need to choose a place on a spreadsheet or on a different spreadsheet to put it. So the output range, we're going to again click out. I'm going to put it down here so that I can do a graph next to this table in a little while. I click out. Now what type of statistics do we want? We want summary statistics. So that might be ticked. That little box might not be ticked. You need to check that. You need to choose summary statistics, and we're going to click OK and let Excel do the rest. And a little table has popped up with all kinds of information on it. As you can see, we've got the mean, we've got standard something, but because we can't see that, I'm going to just slide that over a little bit. Standard error. We have a median and a mode, which are very interesting but not really much use. We've got standard deviation. Standard deviation is useful, but normally at school we don't have big enough sample sizes. But another one that might be useful is the range. So if you have a very limited number of repeats, you might want to use the range instead of the standard error. For my example, I'm just going to use the mean and the standard error. Now, I need to just label these columns so that I know exactly what's in each one. So this one would be for the glucose broth. Column 2, we've got fructose. And in column 3, we've got lactose. And I'm going to copy those 3 means. Because these are whole cells, I'm actually going to round them off. So 29.2 rounds to 29, 51.4 rounds to 51, and 1.6 rounds off to 2. So those are my means. I also want the standard error, and that is over here. Let me just highlight that so that we've got it nice and clear. Make it in that orange color. So we've got that one, and that one. And copy them, and I'm going to paste them in there. So there are my standard errors. Okay, so we've got our mean, we've got our standard error, and now we're ready to draw a graph. So to draw a graph, we are going to highlight what we need. Now I've found it easiest to change the headings slightly so that my columns have got shorter labels. And if I highlight my 3 labels and my 3 means, Excel will draw the graph for me. So I'm going to go to Insert, we need to put in a column graph because it's discrete or categorical data, and we just want a plain column graph. And because I've highlighted the headings, I've got those headings there already. And the very first thing you need to do with your graph is take out the chart title because it's in the wrong place. Your chart title or your figure title should be underneath here, and it's fine to just copy the table title because you are graphing the same thing, and just make sure that you have got figure instead of table. So we've got figure 1, the effect of different types of sugars. Now this graph does not yet have enough information. We do need axes titles. So if you click on the little green emergency button up here, on the Mac I believe it's somewhere up here, we want axes titles. We click on axes titles and you can see it opens up an option for us to put in an axis title. So my axis title here is the number of yeast, the increase in yeast cells, after 24 hours of incubation. This axis title is the type of nutrient in the broth. That is now correct. Okay, now what are we going to do about these standard errors? We want to put in error bars, because those error bars are going to help us determine whether our data is reliable or not. If you choose to put in range bars, you can do exactly the same. I'm just going to be doing it for the error bars. So again, I've clicked on my chart to make it active. I'm going to click on my plus sign, and down here you can see there's a little label that says error bars, and the minute I hover my mouse over error bars, it pops in some lines. But look at those lines, they're all exactly the same, and these numbers are not exactly the same. So there's something going on there that we need to fix. So let's untick that and go to the arrow. We're going to go down and across to more options, and a little menu pops up at the side. Now you want to have both, because the error bar must be the standard error above the mean and the standard error below the mean. So make sure that both is clicked. It's that one right there. If we scroll down a little, I'll move my face across a little. We don't want a fixed value. We want to have a custom value, and we want to specify the value. So you're going to click on custom and you're going to click on specify the value. Now this dialog box is asking you to put in all the values for the positive standard error. So that's all the values for above the column. So you're going to click on that to pop you out, and you're going to highlight all your standard errors and pop out again. Now we're going to have lovely lines above the column, but we need lovely lines below the column as well. So we're going to go for the negative error value, and we're going to do the same thing. Okay, so here we have got our error bars, and you can see that this error bar is running from about 29 and it's going down to about 23, 24, which is about 5. So we know we've got it right, and it's the same distance above. This error bar is much, much smaller, which we would expect, and this error bar is smaller still, which we would expect from the numbers. So always check to see that your error bars match the information in your table. So there we have it. We have found our standard error, or you might have chosen to go with the range. We have plotted the data, we've included the error bars, and this little graph is ready to go straight into your report with the heading underneath. Now, a lot of my students say to me, what do I do now? What do I do with this information? And should I include the raw data in my report? And I say, yes, you should include the raw data. The raw data is valuable because this is where your analysis starts. So just before we start looking at that, I'm going to take a color out of there because I wouldn't put color in my report, and I'm going to make this a nice table. Because now I can copy this directly into my report, and I can copy this directly into my report. Your analysis of the data starts with your raw data. If we look at these numbers, are there any numbers there that stand out, that look like they might be a little bit too different? And there is one. Is this repetition number 5 for the glucose broth only had an increase in 10 cells, whereas the others were increasing by 30 and 40. So this is quite substantially below the mean. So I would highlight that so that I can remind myself to talk about it when I analyze my data. So it's possible that something happened when we were doing that repetition. If we look at our other data, they're all fairly similar, fairly close to the mean, and these are also fairly similar and fairly close to the mean. That one seems to be a little bit higher. You might want to highlight that as well. Now, I want to caution you about using the word outlier. If you use the word outlier, you need to have mathematically demonstrated that these numbers are outliers. So avoid it unless you are able to do that. But you can certainly discuss the fact that these numbers were unusual and they need closer inspection. So that's number 1. Over here, if we look at our graph, when we've got standard error bars, or any error bars, but these are standard error, you can see that these bars don't overlap. They're completely separate. So in this case, with the error bars, there's no overlapping. We can say that these 3 samples are significantly different because the error bars do not overlap. If the error bars did overlap, we would have to say that they were not significantly different. And that's about it in terms of interpretation, just from what we've got here. I hope that was helpful, and all the best with writing your student experiments.